Hello, and welcome to a little video about solving exponential equations. Now, if you recall in our last lesson, we were solving for missing values of logarithms, and in that lesson, what we ended up having to do for most of the equations is take those logarithmic equations and turn them into exponential ones. So, what we're going to do today is take exponential equations with unknown parts and turn them into logarithms to help us solve it. Now, the very first thing we need to make sure is that the exponent and logarithm are in those standard forms, meaning all by themselves. So let's take a look at the first problem. In the first problem, we have 45 times 3 to 2 to the x. Now, what we want to get rid of is that 45, because usually what we have is a base with an exponent equals something. And that's the form we use to turn into a logarithm. So let's do that. First things first, we're dividing both sides by 45 to get rid of it on the left-hand side. What we are left with here is 3 to the 2x equals 7. Okay, now what we have to do is turn this into a logarithm. Remember, follow the clockwise rotation. The base of the logarithm is the same as the exponent. So we have log base 3 of 7 equals 2x. Now the x isn't quite by itself just yet. What we need to do here is divide both sides by 2. So let's do that. All right, so we have log base 3 of 7 all over 2 equals x. All right, go ahead and plop that into your calculator, and we should get about 0.885. And I rounded, of course. All right. Now, I do have a link to a logarithm evaluator. If you were to do this, what you would have to do is first evaluate log base 3 of 7 and then divide that number by 2. So just as a side note, in case you were doing that by hand, what I really ended up doing is getting 1.77-ish over 2, and that's how I got my decimal. Just in case you were curious about how I entered that into my calculator. Right, let's try the next one out. Ooh, okay, same idea. We need to get rid of that 128, so let's divide out that 128. Okay, so I have 2 to the x over 2 equals 1/2 or 0.5. Now we have an unknown in the exponent. Let's turn that into a logarithm. We get log base 2 of 1/2 equals x over 2. And what we need to do is multiply both sides by 2 to get rid of that over 2 and to get x by itself. So we get 2 log base 2 of 0.5 equals x. Now, if you're using that calculator link that I gave you, you would get 2 times log base 2 of 0.5 is -1. So, 2 times -1 is -2. And we have an answer for x. Okay, very nice, not too bad. In the first one, we had an exponent that had multiplication in it, and in the second one, we have an exponent with some division in it. Not too bad, not too bad. All right, the next one I'd like to do with you is this one. All right, now we may not see the multiplication happening, but that 380 being right next to the e implies multiplication. So let's undo that. Oh, that's an ugly line. Let's undo that 380 times e by dividing both sides by 380. I'd like to remind you that e is an actual number. It's Euler's number. It's 2.72, etc., etc., etc. And e, when we give a logarithm a base e, just as a little reminder, is actually ln, our natural logarithm. So when we use Euler's number, we use a natural log. Okay, now let's turn it into a logarithm. So since log base e, that's what we would get, I'm actually going to write ln of 0.1 equals x over 4. This is a nice one. You can do this one in your calculator because we do have an ln button. You don't need to use the link I gave you. What I'm going to do here is multiply both sides by 4. By the way, your phone calculator has an ln button as well. So we have 4 natural log of 0.1 equals x. Plop that all into your calculator. I think I just typed it in all together, and I got negative 9.21. Okay. Well, I guess that's pretty much it. I wanted to make sure that in this video I showed you some examples of multiplication in exponents, some division in exponents, and of course a natural logarithm. Remember that if you get, I know I don't have really an example here, but just as a reminder, if you get a log base 10, you can use the handy dandy log button on your calculator. So on your regular calculator or on your phone, the log button that you see is log base 10. So that's quite convenient. Okay, if you have any questions about solving these, please let me know or ask your teacher. Otherwise, have a wonderful rest of, well, whatever day it is for you. Bye.